we are asked if a and b are integers, is b odd? And we're given these statements. So this question is a review of the properties of odd and even numbers, and these are the properties that you should remember. So, by the way, this is a distinction between properties of addition and subtraction, multiplication. There's a couple of things to remember. When you're adding and subtracting, if you're adding numbers or subtracting numbers that are the same type, so two odds or two evens, the result is always even. Whereas if you're adding or subtracting numbers of different types, so an odd and an even, or an even and an odd, the result's always going to be odd. And for multiplication, there's also two things worth remembering. One is that the only way to get an odd result is if you multiply two odds or two or more odds. In other words, all of your factors have to be odd, and then the product will be odd. Whereas if you have an even in there for multiplication, if at least one of your factors is even, then the product is going to be even. So with these rules in mind, let's take a look at this question. And then we're asked whether b is odd, a and b are integers, and then we're given that 5a squared plus 20a plus 34 is odd. Well, so 5 times a squared is an odd times a squared, and we don't know whether that's odd or even because it could be odd times odd or odd times even, so I'm just going to leave that as 5a squared for now. But 20 times a is an even number times a, which means this product is going to be even, because if you remember, as soon as you have an even in there, the product becomes even. And then 34 itself is even. We know that this thing is odd. So the first step usually is try to convert as much as possible. You can get rid of the numbers and turn into a statement of odd with the words odd and even in there. Now, even and even, those are two numbers that are the same, or they're either two numbers of the same type, so the result is going to be even. So far we have 5a squared plus an even gives us an odd. And now we work backwards. We know the only way to get an odd if you're adding is if these two are different types. So if we have an even here, that means this has to be odd. So 5a squared is odd. And then using our rules of multiplication, we know that if you're multiplying and the result is odd, all of them have to be odd, which means that a squared has to be odd, which means that a times a is odd. And again, the only way to get an odd is if they're both odd. So a is odd. This is what we learned from statement number 1. Now, turns out we didn't have to go through all of this because the question is about b and statement 1 tells us only about a, but just as you'll see in a second, it's going to make combining the two statements easier. That's why, and also to practice this method, we went through it. So we know from statement 1 that a is odd, but because we're asked for b, this is not sufficient. Let me get rid of this in the interest of space. And let's take a look at statement number 2. Now, statement number 2 tells us that a times b plus 3 is an even integer. Well, we know from our rules for multiplication with the properties of odds and evens that if one of these is even, the entire thing is even. So we could have, for example, that a is even and that b plus 3 is even. Alternately, we could have that a is even and b plus 3 is odd. As long as one of them, either a or b plus 3, is even, the product is gonna be even. So this is odd. Or we could have that a itself is odd and b plus 3 is even. The only thing we can't have is both of them be odd. So if b plus 3 is even, again, to get an even, these two have to be the same type. If this is odd, b has to be odd as well. Now, if b plus 3 is odd, and if, again, to get an odd, they have to be different types. If this is odd, then b would have to be even. And finally, with the even, we saw that b would have to be odd. So statement 2 is not sufficient as well to tell us what b is, whether it's odd or not, because there is a situation where it could be, an instance where it could be even. What about combining them? Well, from statement 1, we know that a is odd, so we can get rid of these two scenarios, which means the only scenario we're left with is if a is odd, that b plus 3 has to be even, and in order for b plus 3 to be even, b would have to be odd, which is a yes answer. It's a consistent answer, and so the answer here is C.